Welcome back, everybody, for another deep dive. This time, we're going to be taking a look at the origins of stone tools. Those, things we kind of think of as like the hallmark of early human ingenuity.
Yeah.
We've got a really cool scientific article here from the journal Archaeometry and a press release about the research. And both of these are exploring a pretty radical idea.
Yeah.
What if Mother Nature had a hand in the invention of stone tools?
Yeah. It's a very intriguing concept that kind of challenges the traditional understanding of, how early humans came up with such a revolutionary technology.
Okay, so just to get us all on the same page, let's start with knapping.
Yeah.
This is the process of, intentionally striking a rock to, like, break off those sharp flakes, right?
Exactly.
Yeah.
Knapping was a game changer for our ancestors.
Mm-hmm.
Imagine suddenly being able to get meat off of carcasses really efficiently, access a whole new level of nutrition.
Right.
And that shift in diet likely fueled bigger brains. And, well, you could argue it set us on the path to becoming human.
Yeah, so napping the original life hack. But here's where things get interesting. We often link napping back to our ancestors' percussive activities, like smashing nuts with rocks.
Right.
But how do we go from like randomly bashing things to intentionally creating those sharp flakes that were so useful for cutting meat?
Yeah, it's a question that's puzzled researchers for a long time.
Yeah.
The connection between, nut cracking and the precise skill of napping isn't really immediately obvious.
Right.
And that's where naturaliths come in.
Naturaliths sounds like something straight out of a fantasy novel.
It does, doesn't it?
But really they're naturally sharp pieces of rock, basically. Mother Nature's ready-made knives.
Right.
And the Archaeometry article argues that these naturalists might be way more common than we previously thought.
Yeah, and that abundance could totally rewrite the timeline of human tool use, potentially pushing it back millions of years.
Millions of years now. That's what I call a deep dive.
Yeah.
The article mentions some pretty compelling evidence for this abundance of naturaliths. Like, what kind of evidence are we talking about here?
Well, for starters, they found naturally sharp rocks in Antarctica.
Okay.
A place where obviously no primate could have napped them, right?
Right.
And then there are thousands of sharp flakes in Oman created by nothing more than water and temperature changes.
So Mother Nature was making some pretty sophisticated tools on her own.
It seems that way.
Yeah.
And the examples go on and on. You've got quartzite flakes formed by crashing waves in South Africa, slaked cobbles embedded in a cliff in Brazil thanks to rock falls.
Wow.
These natural processes were just churning out sharp rocks all over the place.
It sounds like Mother Nature was running her own prehistoric stone tool workshop long before humans ever entered the picture.
Yeah, the article even points to sharp phonolite cobbles that they found near Oldowan tools in Kenya.
Oh, wow.
Which proves that, naturalists existed in the right place at the right time.
Yeah.
This abundance of naturally sharp rocks, totally changes our perspective on the timeline of early tool use.
Okay, so, but this raises kind of a crucial question. If these naturalists were so readily available, why did early humans even bother napping their own tools?
That's a great point.
Yeah.
It's a question that the Archaeometry article tackles directly.
Okay.
They offer several possibilities.
Yeah.
One is that naturalists weren't always, as abundant in every environment.
Okay.
Imagine a group of early humans, and they need a certain number of sharp flakes to process a large kill. They might have come up short if they were only relying on naturalists.
So it's about consistency of supply being able to meet those demands.
Exactly.
Yeah.
Another possibility is that napping, provided more control over the shape and quality of the cutting edges.
Okay.
With naturalists, you're limited to whatever nature provides.
Yeah.
But napping allows for customization.
Mm-hmm.
You can create the perfect tool for the job.
So early humans were already starting to think about like efficiency, tailoring their tools to specific tasks.
It seems that way.
Yeah.
And the article highlights another really intriguing possibility.
Yeah.
Early humans might have actually learned from naturaliths.
Oh.
As they used those ready-made tools, they started to understand what features made a good cutting edge. The shape, the angle, the type of rock.
Right.
It's like a rudimentary form of biomimicry, observing and adapting natural designs.
That's fascinating.
Yeah.
So they're using these naturalists, they're realizing what works best, and then they're taking that knowledge and trying to recreate those features themselves.
Precisely.
Yeah.
And that brings us to the heart of the Archaeometry article, the emulation hypothesis.
The emulation hypothesis, it sounds like a real turning point in how we understand the development of early technology.
It really does challenge our traditional view of, human ingenuity.
Yeah.
For years, we've focused on intentionally napped tools as, the sign of early human intelligence.
Right.
But what if the real ingenuity lay in, recognizing the potential of those naturally sharp rocks and incorporating them into their lives? That resourcefulness and adaptation to their surroundings, that's a different kind of intelligence, wouldn't you say?
Absolutely. It's a very humbling thought. You know, this seemingly simple idea that a sharp rock could have played such a crucial role in our, evolutionary journey. It makes you wonder what other simple technologies we might be overlooking in the archaeological record.
Yeah.
Have we been so focused on finding those complex tools that we've missed other signs of early ingenuity?
It's certainly a possibility. And the emulation hypothesis brings up another, challenge. How do we differentiate between a naturalith that was simply lying around and one that was intentionally used as a tool?
Right.
If they were so common, how do we know which ones were actually selected and used?
It's like searching for a needle in a haystack, but the haystack is made of sharp rocks.
Right.
How do researchers even begin to approach that challenge?
It requires a fresh perspective, looking for subtle clues that might have been overlooked before. We need to kind of think like those early humans, considering the context of where these rocks are found. Are they clustered in specific areas? Do they show any signs of wear or damage that suggest they were used for cutting? Are they found alongside animal bones or other evidence of food processing?
So it's like detective work, piecing together these tiny fragments of evidence to build a bigger picture of how early humans interacted with their environment.
Precisely. And we can even look to the present for clues. Observing how other primates interact with sharp rocks like chimpanzees using them to crack nuts might give us insights into how our own ancestors started experimenting with those percussive actions that eventually led to knapping.
It's fascinating to think about those connections between our behavior and the behavior of, our primate cousins.
Yeah, it highlights the deep evolutionary history we share.
Yeah.
But the emulation hypothesis also pushes us to consider the experimental side of things. By replicating how naturaliths are formed and how they might have been used for cutting, we can compare those results to the archaeological record and test specific hypotheses about the mechanics of those early tools.
So we're talking about getting our hands dirty, literally bashing rocks together to understand how those sharp flakes were produced.
Exactly. And it's not just random smashing. These experiments can help us understand the force needed to create a usable cutting edge, how different types of rocks fracture, how those shapes and angles influence their effectiveness as tools. It's like bringing those prehistoric technologies back to life, trying to unlock the secrets of how they worked.
It sounds like a combination of scientific rigor and good old-fashioned experimentation, maybe even a little bit of Indiana Jones thrown in for good measure.
Perhaps. Yeah. But ultimately, it's about challenging our assumptions and getting a clearer picture of, our species' origins.
I can see why you get so excited about this research. It's not just digging up old bones and rocks. It's about understanding the very essence of what makes us human.
And that story is still being written. This research might even have implications for the future of technology.
Okay, now I'm really intrigued. What could the emulation hypothesis tell us about where technology is headed?
Well, for centuries, we've focused on, creating increasingly complex technologies, often trying to control or even overcome nature.
Right.
But what if we took inspiration from our ancestors and looked to nature for solutions, much like they did with naturaliths?
So instead of reinventing the wheel, we look to nature to see how it's already solved problems.
Exactly. Think about the incredible things nature has created: materials as strong as spider silk energy sources, as efficient as photosynthesis. By studying these natural processes and understanding the principles behind them, we could unlock a whole new era of bio-inspired technology.
It's not just about copying what nature does, but about understanding the why behind it.
Precisely. That deeper understanding could lead to groundbreaking discoveries and truly innovative technologies. Imagine if we could create self-healing materials or energy sources that mimic the power of the sun.
Those are some ambitious goals, but the idea of, looking to nature for solutions is really inspiring.
Nature is the ultimate innovator. It has been experimenting and refining its designs for billions of years.
And we're only just beginning to catch up.
It's a humbling thought. It suggests that perhaps we've been a bit too quick to define ourselves solely by our complex technological achievements.
So the emulation hypothesis is suggesting that our technological prowess might actually be rooted in something as simple as recognizing the potential of a sharp rock.
It's a reminder that we are a part of nature, not separate from it, and perhaps the greatest discoveries come not from trying to dominate nature, but from observing and learning from its wisdom.
It's like we've come full circle. We started with early humans observing and learning from nature, and now we're realizing that that same approach could be the key to, future innovation.
Yeah, it is pretty amazing how much we can learn from studying our past. The emulation hypothesis, it isn't just rewriting our understanding of the Stone Age, it's offering like a blueprint for a more sustainable and harmonious relationship with the natural world.
It's a reminder that we're not just inventors, we're also observers, learners, adapters, and sometimes the simplest solutions are the most profound.
I think that's a really great takeaway for our listener. This deep dive into the world of naturaliths and the emulation hypothesis has hopefully, sparked some new perspectives on the origins of technology, human ingenuity, and our place in the grand scheme of things.
Absolutely. And if you want to learn more, we've got links to the Archaeometry article and that press release in the show notes. It's a really fascinating read.
And who knows, maybe this deep dive will inspire you to go out and make some groundbreaking discoveries of your own. After all, there are still countless mysteries hidden in the natural world just waiting to be uncovered.
That's all for today's deep dive, but keep those brains buzzing because there's always more to explore, more to discover, and more to wonder about. Until next time, stay curious.